Hello, in this lecture we'll find out the length of line segment X using two different methods. In the drawing we have a semicircle inside a quarter circle. We know that side AO equals to 6 units. Side AC is tangent to the semicircle at this point. And we want to find out the length of side AC that is equal to X. So we'll start with the first method. We define the center of this semicircle as P. We define the point of tendency of tangent AC with this semicircle as point D. So here, because of the fact that this is a quarter circle, then point O must be the center of the quarter circle, and the angle AOB must be equal to 90 degrees. So point O is the center of the quarter circle, and point A is the point of the quarter circle itself. And this is exactly the definition of a radius. That is to say, AO is the radius of the quarter circle that is equal to 6 units. So we know that the radius of the quarter circle equals to 6 units. And here OB will be also the radius of the quarter circle because of the fact that it starts from the center of the quarter circle, that is to say from point O, and that's at point B, that is the point of the quarter circle itself. Therefore OB is the radius of the quarter circle that is equal to 6 units. But OB, it is not only the radius of the quarter circle, but it is also the diameter of the semicircle. So we know that the diameter of the semicircle equals to 6 units. Therefore, the radius of this semicircle will be equal to half of it. That is to say, it will be equal to 3 units. So the diameter, the radius of the semicircle is equal to 3 units. So here, point P is the center of the semicircle, and point O is the point of the semicircle itself. And this is exactly the definition of a radius. That is to say, OP is the radius of the semicircle that is equal to 3 units. And exactly for the same reason, PB is also the radius of the semicircle that is equal to 3 units. Nice same at PB starts from point P, that is the center of the semicircle, and ends at point B, that is a point of the semicircle itself. And this is exactly the definition of a radius, that is to say, PB is the radius of the semicircle that is equal to 3 units. We will join points P and D together by a straight line. Here, point P is the center of the semicircle. Point D is the point of the semicircle itself, and this is exactly the definition of a radius. That is to say, PD is the radius of the semicircle that is equal to 3 units. We will join points A and P together by a straight line. In the next step, I present to you a new rule. This is actually rule number 1. According to rule number 1, the length of two tangents from a common external point to a circle are equal. So I read rule number 1 again. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have the external point P, here point P is an external point because it is not located inside the circle, nor on the circle itself, but it is located outside the circle. Therefore point P is defined as an external point of this circle. So if from the external point P we draw two tangents to this circle, here the first tangent is tangent here the first tangent is tangent to this circle at this point, point A. Point A is the point of tendency of the first tangent with this circle, and we'll draw also the second tangent from point P to this circle. Here the point of tangency of the second tangent with this circle is point B. So PB is the second tangent to this circle. According to rule number 1, the lengths of two tangents, that is to say the length of the first tangent is PA and the length of the second tangent is PB. So the lengths of two tangents from a common external point, the common external point is point P, to a circle, 2 points A and B are equal. That is to say PA equals to PB. According to rule number 1, in this drawing, PA equals to PB because of the fact that whenever you draw from a common external point, in this case from point P, two tangents to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA equals to PB. Okay, so we can implement rule number 1 in our drawing. In our drawing, we have the common external point, point A. From the common external point A, we have two tangents to this semicircle. The first tangent is tangent AO, the second tangent is tangent AD. AD is tangent to this semicircle is point D. Point D is the point of tendency. Then, according to rule number 1, whenever you have two tangents to a circle from a common external point of that circle, then the length of those two tangents will be equal to each other. In this case, AO equals to AD according to rule number 1. So I can write down that here AO equals to AD according to rule number 1. But here AO equals to 6 units according to what is given as the question. So I can write here that AO equals to 6 units. And from this equation 6 equals to AO equals to AD, we will derive that AD is also equals to 6 units. AD equals to 6 units. Okay. So if you write down in the drawing that AD, this line segment AD is equal to 6 units. So in the next step we prove that the right triangle AOP can go into the right triangle APD according to side rule. We prove that the right main triangle AOP can go into the right triangle APD according to side rule. So I write it down. The right triangle AOP, the right green triangle AOP I repeat again, the right green triangle AOP can go in, this is the same, can go into the right triangle APD, and they can go into each other according to side rule. Okay, so why those two triangles can go into each other? First of all, side AO equals to side AD equals to 6 units according to rule number 1. AO equals to AD equals to 6 units. And AO equals to AD equals to 6 units according to rule number 1. In addition, AP equals to itself. It is a common side that belongs to both triangles. So AP, side AP equals to itself. It's a common side that belongs to both triangles. And finally, side OP equals to side PD equals to 3 units. It is the radius of the semicircle. OP equals to PD equals to 3 units. It's the radius of the semicircle. Okay, OP equals to PD equals to 3 units. So we actually proved that all 3 sides of the right green triangle AOP can go into all 3 sides of triangle APD. Therefore, the right green triangle AOP can go into the right triangle APD according to side rule. And from the fact that those 2 right triangles can go into each other, we will derive that those 2 angles are equal to each other according to the rule that corresponding angles and congruent triangles are equal to each other. Those 2 triangles can go into each other, therefore those 2 corresponding angles will be equal to each other. For angle OAP, this angle equals to this angle that is actually angle PAD. According to the rule that corresponding angles in congruent triangles are equal to each other. Okay, angle OAP equals to angle PAD. So if we define angle OAP as theta, and angle OAP equals to theta according to our definition, so from this equation theta equals to angle OAP equals to angle PAD, we will derive that angle PAD is also equals to theta. Angle PAD is also equals to theta. So this angle PAD is also equals to theta. So both those two angles are equal to theta. In the next step, we'll focus on triangle AOP, the green triangle AOP. In this green triangle AOP, we know that triangle theta equals to OP over AO. OP over AO. I repeat again, in the right triangle AOP, triangle theta equals to OP over AO. In the right triangle AOP, triangle theta equals to OP over AO. OP equals to 3 units and AO equals to 6 units according to what is given as the question. So in conclusion, we found out that triangle theta equals to 3 over 6. We divide both the numerator and the denominator of this side of the equation by 3, and we get that in conclusion triangle theta equals to 3 over 3, that is 1, and 6 over 3 is 2. So in conclusion, we found out that triangle theta equals to 1/2. Okay, triangle theta equals to 1/2. In the next step, we'll join together points O and C by a straight line. So we created here triangle AOC. So we'll present to you the law of cosines, and we will implement the law of cosines in this triangle AOC. Okay? So what is the law of cosines? The law of cosines is true in any triangle. So if we have triangle ABC that could be any triangle, this is triangle ABC. And we know that side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length, and the angle between side AB and side AC is alpha. Then according to the law of cosines, we will get that C squared equals to A squared plus B squared minus 2 times A times B times cosine alpha. I repeat again, in this triangle ABC, C squared equals to A squared plus B squared minus 2 times A times B times cosine alpha. So we can implement this, the law of cosines in triangle AOC. So we'll copy triangle AOC in this page, and we will implement the law of cosines on triangle AOC. So this is triangle AOC. AO equals to 6 units according to what is given under the question. AC is the line segment that we are looking for, that is equal to X. And what is the length of OC? O is the center of the quarter circle. C is the point on the quarter circle itself, and this is exactly the definition of a radius. That is to say, OC is the radius of the quarter circle that is equal to 6 units. Okay? So here, OC, side OC equals to 6 units. And angle OAC equals to theta plus theta, that is 2 theta. So, according to the law of cosines, we get that in this triangle AOC, this will be equation number 1. We get that OC square equals to AO square plus AC square minus 2 times AO times AC times cosine 2 theta. I repeat again, according to the law of cosines, OC square equals to AO square plus AC square minus 2 times AO times AC times cosine 2 theta. Okay? So here, OC equals to 6 units, therefore OC square is 6 squared, that is 36, and it is equal to AO squared. AO also equals to 6, so AO squared is 6 squared, that is 36, plus AC squared. AC equals to X, so AC squared is X squared, minus 2 times AO is 6, times AC is X, times cosine 2 theta. So in this equation number 1, we have 36 on both sides of equation number 1, so 36 will get cancelled. So what is left after we cancel 36 on equation number 1? In this side of equation number 1 we have 0, that is equal to X squared, minus 2 times 6 is minus 12, so this expression in conclusion will be equal to minus 12 X times cosine 2 theta. Here we will add to this equation 12x cosine 2 theta, and we get that according to equation number 1, to 12x cosine 2 theta equals to x squared. I repeat again, according to equation number 1, 12x cosine 2 theta equals to x squared. Here we will divide this equation number 1 by x. Here it is allowable to divide equation number 1 by x because of the fact that x is the length of side AC, that is a positive number. That is to say, x can never be equal to 0. That is the reason that it is allowable to divide this equation number 1 by x. So we divide this equation by x, and we get here that x will get cancelled, and we left only with 12 times cosine 2 theta. That is equal to x squared over x is x. Okay? So according to equation number 1, 12 times cosine 2 theta equals to s. So the only thing that is left to do in order to find out the value of line segment x, the line segment that we are looking for in this question, in this lecture, is to find out the value of cosine 2 theta. Okay? And actually we have a trigonometric identity for cosine 2 theta. According to the following trigonometric identity, cosine 2 theta equals to 1 minus tangent square theta over 1 plus tangent square theta. Okay, so we have this trigonometric identity that cosine 2 theta equals to 1 minus tangent square theta over 1 plus tangent theta. We have already found out that tangent theta equals to 1 half. So we can write here that tangent theta equals to 1 half. Now we can substitute tangent theta in this trigonometric identity by 1 half. We'll do it now, and we get that according to this trigonometric identity, cosine 2 theta equals to 1 minus tangent square theta. Tangent theta equals to 1 half. If tangent theta equals to 1 half, it means that tangent square theta will be equal to 1 half squared over 1 plus tangent square theta, and tangent square theta equals to 1 half squared. So cosine 2 theta equals to 1 minus 1 half squared is 1/4 over 1 plus 1 half squared is 1/4. So here cosine 2 theta equals to 1 minus 1/4 is 3/4, and 1 plus 1/4 is 5/4. So here we have 4 in the numerator and 4 in the denominator, so 4 will get cancelled, and we got that cosine 2 theta, in conclusion, cosine 2 theta equals to 3 over 5, that is 3/5. Cosine 2 theta equals to 3/5. And according to equation number 1, we found out that twelve times cosine 2 theta equals to x, equals to x. Now we can substitute cosine 2 theta in this equation number 1, by 3/5. We'll do it now and we'll get that according to equation number 1, 12 times cosine 2 theta is 3/5 equals to x. So here actually x, according to equation number 1, x equals to 12 times 3, that is 36 over 5. 36 over 5 is 7.2. So we found out that x equals to 7.2 units. So here x, that is actually equal to side AC, it is equal to 7.2 units. Okay, we finished with the first method. In the next step, I will present to you how to find out the length of side AC that is equal to x according to the second method. In the second method, we will use in all the fields that we already found out in the first method. Here the center of this semicircle is at point P. The point of tendency of tangent AC with this semicircle is at point D. We already found out that this angle equals to 90 degrees. OP is the radius of the semicircle that is equal to 3 units. PB is also the radius of the semicircle that is also equal to 3 units, of course. PD is also the radius of the semicircle that is equal to 3 units. We have already proved that those two right triangles, triangle AOP and triangle ABD, can go into each other according to side rule. And from the fact that those two triangles can go into each other, we conclude that those two angles are equal to each other. So if one angle equals to theta, then the other angle will be also equal to theta 2. So all those things we already did in the first method, and from this point we do the second method. In the second method, we will do a construction. We will extend line segment AC by straight line, and we will also extend line segment OB by straight line until they intersect with each other. We will define the intersection point between the extended line segment AC and the extended line segment OB as E. Actually, we created here right triangle AOE. In this right triangle AOE that we created here, we know that AP, line segment AP, is angle bisector of angle OAE. That is to say, the angle bisector AP divides angle OAE into two halves. Each half equals to theta. For that reason, AP is the angle bisector of this triangle AOE. So I present to you the angle bisector theorem. I'll repeat again. Here AP is the angle bisector of angle OAP because of the fact that line segment AP divides angle OAE into two halves. Each half equals to theta. For that reason, AP is the angle bisector of triangle AOE. So, in the next step, I will present to you what is the angle bisector theorem. Okay? The angle bisector theorem. So if we have a triangle ABC, that could be any triangle. This is triangle ABC. And here AD, line segment AD is the angle bisector of angle BAC. That is to say, it divides angle BAC into two halves. Each half equals to theta. For that reason, AD is defined as angle bisector. And according to angle bisector theorem, we get that the angle bisector in a triangle in this drawing, the angle bisector is AD, so we write in brackets that we are relating to side AD. So the angle bisector in a triangle divides the side that it is. In our specific drawing, we have the angle bisector AD that eats side BC. So write down in the bracket that in this drawing we are relating to side BC in a ratio I repeat again, the angle bisector AD, each side BC, and divide it into two parts. The first part is BD and the second part is DC. And the ratio between those two parts is BD over DC. Very simple. That is the ratio that angle bisector AD divides side BC, and that ratio is equal to the ratio between the angle's legs. Between the angle's legs. We are relating to the angle that has been bisected. That is to say, we are relating to angle BAC that has been bisected into two halves. And the legs of angle BAC has two legs. The first leg is AB and the second leg is AC. And the ratio between those two legs is AB over AC. Okay, write it here. In conclusion, according to angle bisector theorem, the ratio between the angle that has been bisected into two halves is AB over AC, and that ratio is equal to the ratio that angle bisector AD bisects side BC. That is actually BD over DC. I repeat again, the angle bisector in a triangle, in this case is AD, divides the side that it eats side BC, and divides it into two parts, BD and DC. And the ratio between those two parts is BD over DC, and that ratio is equal to the ratio between the angle's legs. We are related to the angle that has been bisected into two parts. That is to say, angle BAC. Angle BAC has two legs, BA and AC, or AB and AC. And the ratio between those two legs is AB over AC. And that ratio equals to the ratio that angle bisector AD divides side BC. And angle bisector AD divides side BC in a ratio that is equal to BD over DC. And that ratio equals to the ratio between the angle's legs, that is AB over BC, AB over AC. So in conclusion, AB over AC equals to BD over DC. Okay, I repeat again that the ratio between the angle's legs is AB over AC, and that ratio equals to the ratio that angle bisector AD divides side BC. That is actually BD over DC. In conclusion, we found out that according to angle bisector theorem in triangle ABC, AB over AC equals to BD over DC. Very simple. Okay, so we can implement the angle bisector theorem in triangle AOE. I copied the right triangle AOE in a new page, and we implement the angle bisector theorem in this right triangle, triangle AOE. Side AO equals to 6 units according to what is given us in the question. AP is the angle bisector of angle OAE. It divides angle OAE into two halves, each half equals to theta. OP is the radius of the semicircle that is equal to 3 units. So this is the right triangle AOE that I copied from the original drawing. So AP is the angle bisector of angle OAE. So for that reason we can implement the angle bisector theorem in this right triangle AOE. According to the angle bisector theorem, the angle bisector AP divides the side that is actually OE, into two parts. The first part is OP, the second part is PE. The ratio between those two parts is OP over PE. OP over PE. And that ratio equals to the ratio between the angle's legs. We are relating to the angle that has been bisected into two halves, that is to say angle OAE. The legs of angle OAE, they are AO and AE. And the ratio between those two legs is AO over AE. AO over AE. And that ratio equals to the ratio that angle bisector AP divides side OE, that is OP over PE. In conclusion, we found out that according to angle bisector theorem, OP over PE equals to AO over AE triangle AOE. This is the question number 1. Here OP equals to 3 units over PE, and it is equal to AO. AO equals to 6 units according to what is given as the question, over AE. So in conclusion, we found out that according to question number 1, 3 over PE equals to 6 over AE. Here we will divide this equation by 3, and we will multiply it by AE, and we will get that according to equation number 1, 6 over 3 equals to AE over PE. 6 over 3 is 2, so I write it down. According to equation number 1, AE over PE equals to 2. Here we will multiply this equation number 1 by PE, and we get that according to equation number 1, AE equals to 2 times PE. That is to say, AE is twice as long as PE. So here we define PE as A. PE is equal to A according to our definition. So we can write here that P equals to A. In the original drawing, we also can write down that PE equals to A according to our definition. And here, according to equation number 1, A equals to 2 times PE, and PE is A. So AE equals to 2A. According to equation number 1, A equals to 2A. You can write here that side AE equals to 2A. In the next step, we will implement the Pythagoras theorem on the same right triangle, triangle AOE. So I'll copy the right triangle AOE in the new page and we will implement the Pythagoras theorem on this right triangle, triangle AOE. We have already found out that A equals to 2A. And here OE, side OE equals to 3 plus A. So this is the right triangle AOE that I copied from the original drawing. AO equals to 6 units according to what is given as the question. O equals to 3 plus A. And we already found out that A equals to 2A. So according to the Pythagoras theorem, here by PT is the evaluation for Pythagoras theorem. We will get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the square of the hypotenuse is AE squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AO squared plus OE squared. So according to the Pythagoras theorem, A squared equals to AO squared plus OE squared. Here A equals to 2A, therefore A squared will be equal to 2A squared. And it is equal to AO squared. AO is 6, so AO squared is 6 squared, that is 36. Plus OE squared. O equals to 3 plus A, so OE squared will be equal to 3 plus A squared. Here we will open the brackets on both sides of equation number 1, and we get that according to equation number 1, two A squared is 4A squared. That is equal to 36 plus 3 plus A squared. 3 plus A squared is 3 squared, that is 9, plus A squared plus 6A. Here 36 plus 9 is 45, so I write it down. 4A squared equals to 45 plus A squared plus 6A. Here we will subtract A squared from this equation, equation number 1, and we get that according to equation number 1, 4A squared minus A squared is 3A squared. That is equal to 45. A squared minus A squared is 0, plus 6A. Here we divide this equation, equation number 1 by 3, and we get that according to equation number 1, 3A squared over 3 is A squared. that is equal to 45 over 3 is 15, and 6a over 3 is 2a. Here we'll subtract 15 and also 2a from this equation, equation number 1, and we get that according to equation number 1, a square equals to a square minus 2a minus 15 equals to 0. So here we have a quadratic equation. The coefficient a in this quadratic equation is 1, the coefficient b is minus 2, and the coefficient c is minus 15. And the variable that we are looking for in this quadratic equation is a, so x equals to a. And the general formula for a quadratic equation for solving a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So we'll put the data inside this formula and we'll find out the value of the values of a because x equals to a. So here a will be equal to minus b, b equals to minus 2, so minus b is minus 2, that is plus 2, plus minus square root of b squared. b equals to minus 2, so b squared is minus 2 squared, that is 4. Minus 4 times a is 1, and c is minus 15. Over 2a, a is 1, so 2a is 2 times 1, that is 2. So here we have a equals to 2 plus minus minus 4 times minus 14 is plus 60, and 60 plus 4 is 64. So inside the root we left only with 64 over 2. So here a equals to 2 plus minus, the square root of 64 is 8 over 2. So here we will have two solutions that are possible for a. The first solution for a is that a equals to 2 minus 8 over 2. 2 minus 8 is minus 6, and minus 6 over 2 is minus 3. So if we know that a equals to minus 3, that is a negative number. But here a is the length of side PE, of triangle APE. And a is a length, it must be a positive number. A is a length, and as a length, it must be a positive number. So it can never be equal to minus 3, that is a negative number, so we cancel this solution and we left only with the second solution, that a equals to 2 plus 8 over 2. 2 plus 8 is 10, and 10 over 2 is 5. So we found out that a equals to 5 units. Okay, equals to 5 units. So I can write here that a equals to 5 units. Therefore 2a will be equal to 2 times 5, that is 10 units. So we found out that P equals to A, that is 5 units, and A equals to 2A, that is 10 units. So in the next step we will find out the length of line segment BE. So BE, from the drawing it is very easy to see that the length of line segment BE is PE minus PB. So I'll repeat again. B equals to PE minus PB. So BE equals to PE equals to 8, that is 5 units, minus PB is the radius of the semicircle, that is equal to 3 units. So in conclusion, we found out that B equals to 5 minus 3, that is 2 units. B equals to 2 units. So we can write here that B equals to 2 units. In the next step we will find out the length of line segment CE. Here from the drawing it is very easy to see that CE, the length of line segment CE equals to AE minus AC. AE minus AC. I'll repeat again. C equals to AE minus AC. We already found out that AE equals to 10 units and CE is the line segment that we are looking for, that is to say it is equal to X, according to what is given as the question. So in conclusion, we found out that CE equals to 10 minus X. Okay, C equals to 10 minus X. In the next step, we will complete the quarter circle to a circle. So we completed the quarter circle to a circle. Now we will extend line segment BO by straight line until it touches the circle. And we will define the touching point of the extended line segment BO and the circle is point M. Point M is the touching point of the extended line segment BO and the circle. Okay. In the next step I will present to you a new rule. This is actually rule number 3. Rule number 3. According to rule number 3, if two chords intersect with each other outside the circle, then the following equation is true. So here we have the external point P. Point P is actually the intersection point between the two chords. So write it down. Point P is the intersection point. The intersection point between those two chords. So here we have the first chord, chord AB. This is chord AB that intersects with chord CD. It's point P. Point P is the intersection point of chord AB with chord CD. Therefore, according to rule number 3, we get here that PA times PB equals to PC times PD. PC times PD. So repeat rule number 3 again. According to rule number 3, if two chords intersect with each other outside the circle, then the following equation is true. That PA times PB equals to PC times PD. Again, PA times PB equals to PC times CD. Okay, so whenever you have two chords that intersect with each other outside the chord, then the following equation is true, that PA times PB equals to PC times CD. PC times PD. Okay, so we can implement rule number 3 in our drawing. Why? Because in our drawing, we have chord AC that intersects with chord MB at point E. Again, chord AC intersects with chord MB at point E. Point E is the intersection point of those two chords. So I write it down. In our specific drawing, we have chord AC that intersects with chord MB at point E. Point E is the intersection point of chord AC with chord MB. I repeat again, here in our specific drawing we have chord AC that intersects with chord MB at point E. Point E is the intersection point of chord AC with chord MB. Therefore, according to rule number 3, we will get that EC times EA equals to EB times EM. Again, EC times EA equals to EB times EM. I write it down. According to rule number 3, EC or C, it is the same, times EA equals to EB times EM. I'll repeat again. Chord AC intersects with chord MB at point E. Point E is the intersection point. Therefore, according to rule number 3, we get that EC times EA equals to EB times EM. Okay? So here, EC equals to 10 minus X. EA equals to 10 units. And it is equal to EB or BE, it is 2 units, times EM. EM equals to here. What is the length of line segment MO? The length of line segment MO, O is the center of the quarter circle and also the center of the circle itself. M is the point on the circle itself. And this is exactly the definition of a radius. That is to say, OM is the radius of the circle, that is also the radius of the quarter circle. That is to say, OM equals to 6 units because it is the radius of the quarter circle, that is also the radius of the circle itself. So MO equals to 6 units, that is the radius of the circle and also the radius of the quarter circle. So MO equals to 6, OP is 3, PB is 3, so it is 6 plus 3, that is 12, plus 2 is 14. In conclusion, we found out that EM equals to 14 units. So 10 minus X times 10 equals to 2 times 14. 2 times 14 is 28. So 28 equals to 10 times 10 minus X. Here we will divide this equation by 10 and we get that here 10 minus X equals to 28 over 10 is 2.8. Here we will add to this equation X and we will subtract 2.8 and we get that here X equals to 10 minus 2.8. 10 minus 2.8 is 7.2. So in conclusion, we found out that X that is actually also equals to AC equals to 7.2 units, and we arrived to the same result in both methods. So X equals to 7.2 units. Here X that is also equals to AC equals to 7.2 units. In the next step I will summarize the lecture. We will start with the first method. So I repeat on the question. We have here a semicircle that is inside a quarter circle. We know that side AO equals to 6 units, and here AC is tangent to the semicircle at this point, and we want to find out the length of line segment AC that is actually equals to X. So here, because of the fact that this is a quarter circle, AOB is a quarter circle, this angle must be equal to 90 degrees, and this point, that is point O, must be the center of the quarter circle. Okay, so line segment OA starts from the center of the quarter circle, that is to say from point O, and ends at point A, that is the point of the quarter circle itself, and this is exactly the definition of a radius. That is to say, OA, line segment OA, is the radius of the quarter circle that is equal to 6 units. Okay, so the radius of the quarter circle equals to 6 units. Here OB is also the radius of the quarter circle for the same reason. That is to say, it is equal to 6 units. And OB is not only the radius of the quarter circle, but it is also the diameter of the semicircle. So we know that the diameter OB of the semicircle equals to 6 units, therefore the radius must be equal to half of it. That is to say, the radius of this semicircle equals to 6 over 2, that is 3 units. P is the center of the semicircle, O is a point of the semicircle itself, and this is exactly the definition of a radius. That is to say, PO is the radius of the semicircle that is equal to 3 units. For the same reason, also PB equals to 3 units, and we join points P and D by a straight line. For the same reason, PD is also the radius of the semicircle that is equal to 3 units. I repeat again, point P is the center of the semicircle. Point D is the point of the semicircle itself, and this is exactly the definition of a radius. That is to say, PD is the radius of the semicircle that is equal to 3 units. Okay, PD equals to 3 units. So PD is the radius of the semicircle that is equal to 3 units. We join together points A and P by a straight line. And then I presented to you rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So here we have this circle, and point P is an external point of this circle. From point P, we draw two tangents to this circle, tangent PA and tangent PB. According to rule number 1, the lengths of two tangents, that is to say PA and PB, from a common external point, that is point P, to a circle to points A and B are equal. That is to say, tangent PA equals to tangent PB according to rule number 1. We can implement rule number 1 in our drawing. In our drawing, we have the common external point, point A. From the common external point, point A, we have two tangents to this semicircle, tangent AO and tangent AD. And according to rule number 1, the length of those two tangents must be equal to each other. So here AO must be equal to AD according to rule number 1. Okay? But here AO equals to 6 units according to what is given as the question. So we can write here that AO equals to 6 units. And from this equation 6 equals to AO equals to AD, we will derive that AD is also equals to 6 units. Here AD equals to 6 units. In the next step we proved that those two right-hand triangles can go into each other according to side rule. Triangle AOP can go into triangle APD according to side rule. So why they can go into each other? First of all, AO equals to AD equals to 6 units according to rule number 1. AO equals to AD equals to 6 units. AP is the constant that belongs to both triangles, so AP equals to itself. And finally, DP equals to PO equals to 3 units. This is the radius of the semicircle. OP equals to BD equals to 3 units. So we proved that all the sides of triangle APD can go into all the sides of triangle APO. Therefore, those two triangles can go into each other according to side rule. And from the fact that those two right triangles can go into each other, we will conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. That is to say, angle OAP equals to angle PAD. So if we define angle OAP as theta, here angle OAP equals to theta according to our definition. From this equation, theta equals to angle OAP equals to angle PAD. We will derive that angle PAD is also equals to theta. Here, this angle is also equals to theta, so those two angles are both equal to theta. Then we focus on the right triangle AOP. In the right triangle AOP, tangent theta equals to OP over AO. Repeat again, the right triangle AOP, tangent theta equals to OP over AO. Here OP equals to 3 units, AO equals to 6 units, so in conclusion we found out that tangent theta equals to 3 over 6. We divided both the numerator and the denominator of this side of the equation by 3, and we got that 3 over 3 is 1 and 6 over 3 is 2. In conclusion we found out that tangent theta equals to 1 half. Tangent theta equals to 1 half. Then we joined points O and C together by a straight line. So we created here triangle AOC. And we implemented the law of cosines in this triangle AOC. So I presented to you the law of cosines. The law of cosines is true in any triangle. So if we have this triangle ABC, that could be any triangle. The length of side AB is A units, the length of side AC is B units, and the length of side BC is C units. And the angle between side AB and side AC is alpha. According to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosine alpha. And we implemented the law of cosines in triangle AOC, so I copied triangle AOC in this new page, and we implemented the law of cosine in this triangle and triangle AOC. AC equals to X according to what is given as the question. AO is also equals to 6 according to what is given as the question. And OC, what is the length of OC? O is the center of the quarter circle. C is the point of the quarter circle itself, and this is exactly the definition of a radius. That is to say, OC is the radius of the quarter circle that is equal to 6 units. So OC is the radius of the quarter circle that is equal to 6 units. So we implemented the law of cosines in this triangle AOC according to the law of cosines, and we know that angle OAC equals to theta plus theta, that is 2 theta. So according to the law of cosines, we get that OC squared equals to AO squared plus AC squared minus 2 times AO times AC times cosine 2 theta. Okay? Here OC equals to 6. Therefore OC squared is 6 squared, that is 36. That is equal to AO squared. AO equals also to 6, so AO squared is 6 squared, that is 36. Plus Here it is AC squared. AC squared, AC is x, so AC squared is x squared, minus 2 times AO, that is 6, times AC, this is x, so it is minus 2 times 6 times x times cosine 2 theta. So here we have 36 on both sides of the equation, so 36 will get cancelled, and we're left only with x squared minus 2 times 6 times x times cosine 2 theta. Minus 2 times 6 is minus 12, so this expression equals to minus 12x cosine 2 theta. So in conclusion, we found out that 0 equals to x squared minus 12x cosine 2 theta. We added to this equation, equation number 1, 12x cosine 2 theta, and found out that according to equation number 1, x cosine 2 theta equals to x squared. Here we divided this equation, equation number 1, by x, and found out that according to equation number 1, here x will get cancelled, and so in this side of the equation number 1 we have 12 times cosine 2 theta, and here in the other side of equation number 1 we have x squared over x is x. So in conclusion, we found out that according to equation number 1, 12 times cosine 2 theta equals to x. So the only thing that is left to do in order to find out the value of x is to find out the value of cosine 2 theta. And we have trigonometric identity for the value of cosine 2 theta. Cosine 2 theta, according to this trigonometric identity, equals to 1 minus tangent square theta over 1 plus tangent square theta. And we have already found out that tangent theta equals to 1/2. So we can substitute tangent theta by 1/2 in this trigonometric identity. We did it, and we got that cosine 2 theta equals to 1 minus tangent square theta. Tangent theta equals to 1/2. So tangent square theta will be equal to 1/2 squared. So it is in the numerator we have 1 minus 1/2 squared over 1 plus tangent square theta. That is to say over 1 plus 1/2 squared. Because tangent theta equals to 1/2 squared. 1/2 squared is 1/4, so this expression equals to cosine 2 theta equals to 1 minus 1/4 over 1 plus 1/2 squared is 1/4. So in conclusion, we found out that cosine 2 theta equals to 1 minus 1/4 over 1 plus 1/4. 1 minus 1/4 is 3/4, and 1 plus 1/4 is 5/4. So in conclusion, we found out that cosine 2 theta equals to 3/4 over 5/4. Here we have 4 in the numerator and 4 in the denominator, so 4 will get cancelled, and we left with cosine 2 theta, that is 3/5. So we found out that cosine 2 theta equals to 3/5. And then we have equation number 1 that states that cosine 12 times cosine 2 theta equals to x, so we can substitute now cosine 2 theta by 3/5. We did it, and we got that 12 times cosine 2 theta is 3/5. That is equal to x. Here 12 times 3 is 36. 36 over 5 equals to x. X equals to 36 over 5, that is to say x equals to 7.2 units. So we found out that here at x that is equal to AC equals to 7.2 units. We finished with the first method. In the next step I will present to you how we found out the length of line segment x according to the second method. In the second method, we used all the things that we have already found out in the first method. Here we have already found out that this angle is a right angle, and AO is the radius of the quarter circle, that is equal to 6 units. OP equals to PB equals to PD equals to 3 units, that is the radius of the semicircle. And here we have already found out in the first method that those two triangles can go into each other according to side rule, and therefore those two angles, they are both equal to theta. From the fact that those two triangles can go into each other, we will conclude that those two angles are equal to each other. So if one angle equals to theta, then the other angle must be equal to theta. So we did all those things in the first method, and in the second method we did another construction. We extended line segment AC by straight line, and we extended line segment OB by straight line until they intersect with each other at point E. Point E is the intersection point of the extended line segment AC and the extended line segment OB. Okay? And then we created here the right triangle AOE. In the right triangle AOE, PA divides angle OAE into two halves, theta and theta. That is to say, PA is the angle bisector of triangle OAE. Therefore, we can implement the angle bisector theorem in this triangle AOE. So first of all, I explain to you what is angle bisector theorem. The angle bisector theorem, if we have triangle ABC that could be any triangle, here AD divides angle BAC into two halves. For that reason, angle AD is defined as angle bisector. And according to angle bisector theorem, the angle bisector in a triangle, in this case it is AD, divides the side that it eats. Angle bisector AD eats side BC and divides it into two parts. The first part is BD and the second part is DC. And the ratio between those two parts is BD over DC. So the ratio that angle bisector AD divides side BC is BD over DC, and that ratio is equal to the ratio between the angle's legs. We are talking about the angle that has been bisected into two halves, that is to say angle BAC. This angle BAC has two legs. The first leg is AB and the second leg is AC, and the ratio between those two legs is AB over AC. And that ratio equals to the ratio that angle bisector AD divides side BC, that is to say BD over DC. In conclusion, we found out that AB over AC equals to BD over DC. Okay, the ratio that angle bisector AD divides side BC is BD over DC, and that ratio equals to the ratio between the angle's legs, that is AB over AC. In conclusion, AB over AC equals to BD over DC. So you can implement rule number 3, the angle bisector theorem in triangle AOE. So I copied the right triangle AOE in this new page. This angle equals to 2 theta, and AP divides angle OAE into two halves. For that reason, AP is the angle bisector of triangle AOE, and so according, we can implement the angle bisector theorem in this triangle AOE. According to the angle bisector theorem, the angle bisector AP each side OE and divides it into two parts. The first part is OP and the second part is PE. And the ratio between those two parts is OP over PE, and that ratio equals to according to angle bisector theorem, that ratio equals to the ratio between the angle's legs. And the angle's legs is the angle's legs is leg AO and leg AE. The angle that is bisected into two halves is angle OAE, and angle OAE has two legs. The first leg is AO and the second leg is AE, and the ratio between those two legs is AO over AE. And that ratio equals to the ratio that angle bisector AP divides side OE. That is to say, is OP over PE. or in conclusion, OP over PE equals to AO over AE. Here OP equals to 3 units, this is the radius of the semicircle, over PE equals to AO is 6 units according to what is given as the equation, over AE. Here we divided this equation number 1 by 3 and we multiplied by AE, and we found out that according to equation number 1, 6 over 3 equals to AE over PE. 6 over 3 is 2, so according to equation number 1, 2 equals to AE over PE. We multiplied this equation number 1 by PE, and we found out that AE equals to 2 times PE. That is to say, AE is twice as long as PE, so we define PE as A. Here PE equals to A according to our definition, and also here P equals to A according to our definition. Therefore, we can substitute P in equation number 1 by A. We did it and we got that A equals to 2 times PE is A, so A equals to 2A. According to equation number 1, A equals to 2A. Here, side AE equals to 2A, according to equation number 1. Then I copied the right triangle AOE in the new page and we implemented the Pythagoras theorem on this right triangle AOE. Here you can see that OE equals to 3 plus A. And also you can see that OE, side OE equals to 3 plus A. Okay. So this is the right triangle AOE. OE equals to 3 plus A, AO equals to 6 units according to what is given as the question. And we have already found out that AE equals to 2A. AE, the hypotenuse A equals to 2A, so we implemented the Pythagoras theorem on this right triangle AOE. In this right triangle AOE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AE squared equals to AO squared plus OE squared. So AE squared equals to AO squared plus OE squared. AE equals to 2A, so A squared is 2A squared, and it is equal to AO squared. AO equals to 6, so AO squared is 6 squared, that is 36, and it is equal to plus OE squared. OE is 3 plus A, so OE squared is 3 plus A squared. So here 2A squared is 4A squared, that is equal to 36, plus 3 plus A squared. We open the brackets here and we found out that 3 plus A squared equals to 3 squared, that is 9, plus A squared, plus 6A. 36 plus 9 is 45. So in conclusion, we found out that according to equation number 1, 4A squared equals to 45 plus A squared plus 6A. We subtracted A squared from this equation number 1, and found out that 4A squared minus A squared is 3A squared, and 3A squared equals to 45 plus 6A. We divided this equation number 1 by 3, and we found out that 3A squared over 3 is A squared, 45 over 3 is 15, and 6A over 3 is 2A. So in conclusion, we found out that A squared equals to 15 plus 2A according to equation number 1. We subtracted 15 and also 2A from this equation number 1, and we found out that according, so here, according to equation number 1, A squared minus 2A minus 15 equals to 0. So we have here a quadratic equation. The coefficient A in this quadratic equation is 1, the coefficient B is minus 2, and the coefficient C is minus 15. And the variable that we are looking for in this quadratic equation is A, so x equals to A. And the general formula to solve a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So the variable that we are looking for in our specific quadratic equation is a. So x is equal to a. So a equals to minus b, b is minus 2, so minus b is minus 2, that is plus 2, plus minus square root of b squared. B is minus 2, so b squared is minus 2 squared, that is 4. Minus 4 times a is 1, and c is minus 15. So here we have minus 4 times minus 15 over 2. So here a equals to 2 plus minus 4 times minus 15 is plus 60, and 60 plus 4 is 64. So inside the root we left only with 64. In conclusion, we found out that a equals to 2 plus minus square root of 64 over 2. The square root of 64 is 8, so here we have two solutions that are possible for a. A equals to 2 plus minus 8 over 2. The first solution for a is a equals to 2 minus 8 over 2. 2 minus 8 is minus 6, and minus 6 over 2 is minus 3. So we found out that a equals to minus 3, that is a negative number. But here a is the length of side PE, and a is a length, it must be a positive number, it can never be equal to minus 3, that is a negative number. So we cancel this solution and we left only with the second solution, that a equals to 2 plus 8 over 2. 2 plus 8 is 10, and 10 over 2 is 5. So we found out that a equals to 5 units. So if a equals to 5 units, 2a is 2 times 5, that is 10. So here AE that is equal to 2a equals to 10 units, and PE equals to 5 units. Okay? Then we actually completed, we found out the length of line segment BE. From the domain it is very easy to see that BE equals to PE minus PB. B equals to PE minus PB. P equals to 5 units. P equals to 5 units. PB equals to 3 units. So B equals to 5 minus 3, that is 2. So BE equals to 2 units. Then we found out the length of line segment CE. From the domain it is very easy to see that CE equals to AE minus AC. Again, AE minus AC equals to CE. Okay, CE equals to AE minus AC. AE equals to 10 units. AC is the variable that we are looking for, that is X. So in conclusion, we found out that CE equals to 10 units. CE equals to 10 minus X. CE equals to 10 minus X units. Then we completed the quarter circle to a circle. And we extended line segment BO by a straight line until it touches the circle at this point. Point M is the touching point of the extended line segment BO and the circle. Then what is the length of OM? O is the center of the quarter circle and also the center of the circle itself, and M is the point of the circle itself, and this is exactly the definition of a radius. That is to say, OM is the radius of the circle, that is also the radius of the quarter circle, that is equal to 6 units. Okay? Then I presented to you rule number 3. According to rule number 3, if two chords intersect with each other outside the circle, then the following equation is true. So here we have chord AB that intersects with chord CD. Those two chords intersect with each other at point B. Point B is the intersection point of chord AB with chord CD. That is outside the circle, of course. Therefore, according to rule number 3, PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. Okay, so we can implement rule number 3 in our drawing. Why? Because in our drawing we have chord AC that intersects with chord OB at point E. Again, chord AC intersects with chord MB. Again, chord AC intersects with chord MB at point E. Point E is the intersection point of chord AC with chord MB. That is, of course, outside the circle. I repeat again. Chord AC intersects with chord MB at point E. Point E is the intersection point of chord AC with chord MB. Therefore, according to rule number 3, we will get that here EC times EA equals to EB times EM. Again, EC times EA equals to EB times EM. Okay? EC times EA equals to EB times EM according to rule number 3. EC equals to 10 minus X, EA equals to 10 units, EB equals to 2 units, and EM, what is the length of EM? The long line segment EM equals to 6 plus 3 plus 3, that is 12, plus 2 is 14. So in conclusion, EM equals to 14 units. EM equals to 14 units. So in conclusion, we found out that 10 minus x times 10 equals to 2 times 14, that is 28. Or 10 minus x equals to 28. We divided this equation by 10, and we got that 10 minus x equals to 28 over 10 is 2.8. We added x to this equation and we subtracted 2.8, and we found out that x equals to 2 minus 2.8. 2 equals to 10 minus 2.8. 10 minus 2.8 is 7.2. So we found out that x that is equal to AC, it is equal to 7.2 units. Here, x that is also equal to AC equals to 7.2 units. So we arrive to the same result in both methods, that x that is equal to AC, it is equal to 7.2 units. Okay? Thank you very much.